All right, we're now going to go over an optimization problem, which is a big deal because these are the types of problems you're really going to actually see like applications for in like the real world. Um, so it's cool. I mean, because like then you like kind of like related rates in chapter two, even though they're difficult, you saw like how they're actually like used in real life, and like that's really cool to kind of get some motivation to like see where this stuff is going in the future. Anyways, we're gonna look at a box problem. Yeah, I mean, it's like I wish that we started with a different problem, but we gotta start with the basic one, okay? That's okay because even in Panda Express when they're making when they're serving your bigger plate and stuff, they gotta have they gotta have materials. They have to make sure they maximize their use of any like cardboard, any paper, everything. So here we have a manufacturer that wants to design an open box with a square base and a surface a surface area of 108 square inches. So they want to figure out what dimensions of the box can they use with you know, with this requirement so that they can get the biggest volume. So they're going to use 108 square inches of surface area and they want to get the most volume out of it. So let's draw a square or a box. So what you can do is draw a square like this. And a 3D trick that you can do is draw the same size square like at a corner like that. And then you can see that's a cube. And then this will be the base. We'll call this the base. And the base has a width of x. And since it's a square, it'll be x by x, so the base will be the area of the base is x squared, and we'll make this h units tall. Okay, so then what you can see is that let's make the sides like some different color. Let's make it like I'm freaking out here. Let's make it like a green or something like that. I mean, I think you get the idea, but the top is open. So the surface area will be equal to x squared plus 4 times, what the heck is up with this marker? Plus 4 times x times h, because you have 4 sides with the width of x and the height of h. So the total surface area is x squared plus 4xh. Hey guys, we want to make this equal to 108. So we're going to make this 108. We're going to make a new equation. 108 is equal to x squared plus 4xh. Now the volume, though, is going to be x squared times h. So we need to find a way to make an equation for volume where we only have one variable because we haven't learned, two variable calculus, not yet at least. So we're going to solve this for h. Yeah, solve this for h and plug it into here. So if we solve this for h, taking away x squared, 108 minus x squared divided by 4x is equal to h. And then so h will be, let's go down here, h will be equal to 27 over x minus 1/4 x, because you have an x squared on top over an x. So now this we can plug into here, And let's set a new equation for volume, where we will have volume is equal to x squared times 27. Let's make this x to the negative 1 to make it easier to work with. X to the negative 1 minus 1/4 x. So here's our one variable equation for volume. Whoop, awesome. Now we want to find how we can get the maximum volume. So what value of x will give you the maximum volume? So for this, we want to see how this volume equation is changing. We want to find the derivative of it. So what is this? Because this is very hard to graph, obviously, at least for the common folk, or for for common world. So dv dx will be equal to, and let's make this actually work. Let's distribute that x squared, so we get 27x minus 1/4 x cubed. So differentiating this. I should have done that first, but same thing. So 27 minus 3/4 x squared. This is the first derivative, but as we've learned, if we find the second derivative, we can determine an inflection point, and we can see if there's a peak or a valley or like a minimum. Here we'll know if there's a maximum or minimum. We'll know where it's increasing or decreasing and find the zeros. But let's find the second derivative. So the second derivative of volume with respect to x will just be 6/4 or negative 6/4 x, or negative 6/4 x, or negative 3/2 x. So we have two equations that we can work with. So this says the second derivative is negative, so it's going to be concave down. We know the graph is concave down, so we know the graph will be like this. So then we know there's going to be a maximum somewhere on this graph. And we can find the max by figuring out where. Let me make this a little bigger, actually, because this is important. Let's do it over here. The maximum, we know it's concave down because the second derivative is negative. So we have a maximum at some value of x. And we can figure out what that value is, because on the left, excuse me, my throat has been really bad this week. On this side, the derivative is the function's increasing, so the derivative is positive after the derivative is negative. So let's find where the derivative is 0, because at the maximum the derivative is 0. So we're going to set this equal to 0. So we're going to 0 is equal to 27 minus 3/4 x squared. Solving this. Let me just go over here. I don't want to squeeze that out over there. Hey guys. 3/4 x squared equals 27 times 4, 108 over 3. X squared equals 108 over 3. 108 over 3 is 36. So x squared is 36. Then x could be positive and negative 6. And since it's a box in real life, x has to be positive 6. Because you can't have a box with a negative width. It doesn't make any sense. Not in this dimension, at least. So the base can have have a width of 6 inches, 36, and the height will also be 6, because everything works out. No, I'm sorry. The height will be, sorry. So the x will be 6 inches, and the height will be 27 over 6. 27 over 6 minus 1/4 times 6. So then that'll be, what is that? 4.5, right? 4.5 minus 1/4 of 6 minus 1.5. 3. So a height of 3 inches and a width or a base length of 6 inches. So yeah, so there we go. 6 inches by 3 inches. Double check mark. I don't need to write again because you can just hear my voice. All right, so I hope that helps. Sorry again, but my voice is really raspy. I need to get some water. But let me know if you have any questions. Feedback is always welcome. I know I still have a lot of practice or a lot of improvement to do. But if you have any questions, feel free to leave something in the comment section, and make sure you like and subscribe if you found something useful. And I'll see you guys in the next video. Bye, guys. See you later.